Hello, this is Gladys Wairimu, and I'll be demonstrating how we implemented Bresenham Line Drawing Algorithm using Vulkan. I have included breakpoints when you see these red circles just to guide me through the explanation. So we started by importing some header files and libraries for Vulkan, and then here we defined the dimensions for the viewport where we'll be displaying the output. Then we went ahead to initialize the validation layer here, and then we continued on to declare Vulkan objects that we'll be using throughout the code. These are the objects that we declared. And then we created a function to initialize a Vulkan instance, swap chain, and device. And also the function is supposed to create a render pass, pipeline, command pool, and more, and other Vulkan objects. And then here in this line of code, we created an if statement and declared some variables to select a physical graphical processing unit. Then here we are still continuing to initialize all those Vulkan objects like the queue. And then in this here, we created a logical device and a graphics queue. And then here is where we are creating a swap chain. And just to recap, this function here, this long function, is just meant to initialize a number of Vulkan features like an instance, a swap chain, a pipeline, a command pool, and more. And that's that function. Then here we created another function called create vertex buffer to create a vertex buffer. Here in this function, we started by defining the line coordinates, the x and y values for the coordinates to draw the line, where this is the starting point and this is the end point. And we got these coordinates from the question. And then here we created another function called create buffer to create a buffer and allocate the memory. And in this function we have a throw statement to inform us when the buffer has not been able to be created, and that's also a good debugging mechanism. And then here we created another buffer called copy buffer, and this function is meant to copy buffer contents using a staging buffer and command buffer. So yeah, here as you can see, we started by creating a staging buffer, copying data from the source buffer to the staging buffer, creating a command buffer and copying data from the staging buffer to the data buffer, and then submitting the command buffer to the graphics queue and waiting for it to finish, and finally cleaning up the staging buffer and its memory. So here in line 311, we start implementing a Bresenham Line Drawing Algorithm. And first of all, we start by defining a vertex structure for the line with coordinates x and y. And then we continue now to create a function for Bresenham Line Algorithm. And this is where the formula is implemented using the while and if loops. And we going on to the next function called create command buffers to create command buffers that will be used for rendering. And as you can see here, we are allocating command buffers, recording command buffers, rendering the pass information, beginning the render pass, ending it, and stopping the recording for the command buffer. That's what that function does. Then here we created another function to draw the line according to the coordinates that we give. And yeah, so here it also binds the vertex buffer and begins the vertex buffer drawing. Then here we have another function called drawFrame, and this function is meant to acquire an image from a swap chain, command buffer, and other objects. And as you can see here, we are acquiring an image from the swap chain, and then this if results is meant to, like, if the swap chain is out of date, it's supposed to like give us an error message. And here this line also submits the command buffer for rendering, and you can see here we have more code to present the rendered image. And that is at the end of that function. Then we created another function here called the cleanup function. Is meant to clean up the resources, swap chain, device, like all the Vulkan objects we've used. We're supposed to clean them here. Yeah, as you can see here, for example, we are cleaning up the descriptor set layout, we're cleaning up the vertex buffer and its memory, we're cleaning up the texture image and its memory, cleaning up the surface and the instances. Yeah, the function is meant to clean up. Then finally we have the main function that calls all those previous functions that we created up there, because as we know, when the compiler is running, it goes directly to the main function to start processing the code. So that's our code. Also, there are header files here for the Vulkan API, and just to show you, yes, we imported all these header files so to help us be able to include in our include statements up here. Yes, the reason that there were these statements able to run without errors was because we included this folder for Vulkan header files. So we encountered a challenge when creating this code, because when it won't run without errors. Just to demonstrate, the code is still building and running. And it has finished running, and as you can see, we have a problem here. So we've tried to debug it. The error message says that there's a mismatch of the return types for these variables. However, we've tried a number of methods to debug it and made sure that the return type of both the values, like for GLFW extensions, and its value are the same. However, it's still bringing the same error, so it will not continue compiling further from line 58. So yeah,